In this video, you will learn how ATU can be used to create a test build platform setup with custom parameter variations, which can be used to evaluate build parameters on your additive machine. Open an ATU project, which you want to use for creating a test build platform setup. An input geometry file is loaded, which will be used as a sample part for our test build. Open the Export Test Build dialog. The dialog shows a platform preview on the right side. It is required to have a machine defined in ATU, including a platform definition. It will be shown in another video how this is done. First, define a new setup. Enter a name for the new setup. You could also enter an additional description on the right side. Then specify the number of rows and columns. 3 rows and 3 columns will result in 9 copies of our input geometry. Select a parameter profile. All build parts will have the parameters of this profile assigned. Let's open the parameter profile to see what parameter values we have. These parameters will be available for variations on our 3x3 build part setup. There are laser parameters like power, speed, and focus, which may be good candidates for parameter variations. Now we can specify parameter variations by selecting cells and right-clicking on the table view. In the context menu, click New Variation to open the Parameter Variation dialog. We can specify the affected range of rows and columns. The selected cell on which the dialog has been opened is pre-selected here. The parameter can be varied along rows or columns. Now select the laser power for the hatch filling path as a parameter. Initially, the power value from the previously selected parameter profile is set on each row. Let's just set some custom power values. While hovering over the table cells, we can see the custom power values. The tooltip text shows the values of each cell. We can see that each row has a different laser power. Let's add another parameter variation. This time we will variate the laser speed along the columns. Of course, you can combine any other parameters in your setup. As long as your project has declared the required parameter as a build part parameter. You cannot use platform-related parameters. We can now see the combined parameter values on each cell of the table, where each table cell represents a build part on the build platform. Let's add a final parameter variation. This time we select only 4 cells and we customize the hatching density. This modifies the toolpath geometry, while the first 2 variations only modified the laser parameters. Note that selecting a parameter variation on the right side affects the selection of cells in the table on the left side. So we can check which area of build parts is affected by each parameter variation. We can now adjust the positions of build parts on the platform. It is possible to adjust the space between parts. We can tilt the lines with the line pulling parameter. We can rotate all build parts by a given angle. The position of the parts on the platform can be adjusted. We can also attach labels to the build parts. They can be freely positioned and sized. Labels will be projected from above onto the part. Therefore, try to place the label where there is a XY planar area. In this view, only one build part is visible. Nevertheless, each part will have its own label attached. In the Layer Stack preview, you can see how the layer polygons are modified in order to add the label to the build part. A report document can be created listing all the parameter values which are used to prepare the test build file. It starts with a list of all parameter values which are defined by the selected parameter profile. And then the varied parameters are listed per build part. Now select an export format. It can be an exporter defined in the current ATU project or an external predefined exporter. Configure the export parameters and the export path. Click Export to start the calculation and file export. The toolpaths for all build parts are now calculated. Then the data is written to the specified file. Thanks for watching this video.